Greetings. My name is Dale Mudd, and I'm a graduate student here in the Astronomy Department at Ohio State University. I'm here to talk with you today briefly about my recent paper with Mudd Stanek, in which we provide a catalog of M33 focused around the ultraviolet, or UV, data from the GALEX Space Telescope. Now, why are we focused on the UV data, you may ask? Don't we learn a lot about stars from the optical? Well, yes and no. UV wavelengths probe a different regime. As stars get hotter and hotter, their peak output shifts to bluer and bluer colors, eventually moving out of even the optical, where our eyes can see. And these hot stars are very important from a stellar evolution standpoint. They're typically the rarest, most massive, and most luminous stars that are born, upwards of 10 times as massive as our own sun. Being very massive, they also have a short lifespan, and are thus useful as direct probes of recent star formation, in addition to being interesting sources in and of themselves. The previous UV catalog of M33 used data from the Ultraviolet Imaging Telescope, or UIT, pictured here. It flew on the Astro 1 mission and took short exposures of many objects of astronomical interest, including M33 in 1990. Our updated catalog uses data from the Galaxy Evolution Explorer GALEX, launched in 2003, and benefits from the numerous technological advancements made in the decades since the launch of the Astro 1 mission. GALEX uses multi-channel plates, which are more sensitive than the photographic plates used by UIT, and allows it to go much fainter. It also has a larger field of view. This is the near UV image of M33 taken by GALEX. The overlain circle is the field of view of UIT. So not only does GALEX have the ability to go much deeper than UIT, but also covers a significant fraction of the galaxy that was not observed before, allowing for the first UV observations for many of these sources. There is still one problem the GALEX detector suffers from in common with UIT, and that is its large full-width half maximum. Shown here is a side-by-side comparison of a specific region M33, with GALEX on the left, UIT in the center, and the male 4-meter telescope and the optical on the right. The optical V-band image has a much smaller full-width half maximum than the UV image, and it is readily apparent that the UV images suffer immensely from crowding issues as a result. To try and minimize these issues, we employ PSF photometry on the GALEX images. We check our photometry by comparing our flex values to both the basic GALEX pipeline data as well as the published UIT catalog. After doing so, we match our stars to data from the local group Galaxy survey to create a final list of stars with data in up to 7 bandpasses. Far UV and near UV from GALEX, as well as U, B, V, R, and I from the ground. Our final catalog has 24,378 sources, which is quite a big leap from the previous UV catalog's 356. Combining all the available bandpasses, the most luminous sources all tend to be cooler stars, peaking in the optical wavelengths rather than the ultraviolet ones. This means they are most likely giant stars, less massive ones that have expanded greatly in size near the end of their lifetimes. Note that the y-axis here has them at 1 to 10 million solar luminosities in their peak bandpasses. If we instead look at only the UV brightest stars, as we expect, they are generally objects that are still climbing in flux in the UV bands, with the brightest peaking around 1 million solar luminosities, and are fainter in the optical by around an order of magnitude. The UV brightest sources, as one might imagine, also tend to be the most crowded. On this plot, we have one optical source that was the best match for 4 separate far UV sources. The large N value in the corner, 12, indicates that each of these UV sources had, on average, 12 potential nearby optical stars to match to, but that this was the best choice for each of them independently. To summarize, we use ground-based data, combined with the Space Telescope GALEX, to create a catalog of nearly 25,000 sources in M33, with photometry spanning from the UV to optical wavelengths. GALEX is able to go much deeper than the previous UV catalog of M33, however it still suffers from a rather large full-width half maximum and crowding issues, which we try to alleviate using PSF photometry. Now, if you'd like to see the catalog in full and learn more, please see our paper posted in the archive at the link below. Thanks for watching!